Okay, students, this is the CP Algebra 1 third quarter quarterly exam review. This is review 2. This is sheet 2, not sheet 1. As I mentioned in the other sheet, I will make mistakes once in a while. You can catch them and see them by checking them in Desmos or Photomath. I think on the last video, I think it was problem 40-something, 41, I did parallel instead of perpendicular, okay? So just be aware as I rush through this, that may happen. Don't forget to pause the video and try the problems yourselves if you haven't tried them already. Okay, so okay, let's do the first few problems together. What graph represents a function? So this represents a function because it passes the vertical line test. You can draw as many vertical lines as you want, and none of them will pass through 2 points at the same time. Same thing here. This passes the vertical line test, no problem. Here you can see the vertical line test fails any of these places. It doesn't fail right there, but it fails in the other places here. It hits 2 points, 1, 2 on the same line. So this one's not, and these two are functions. Okay, state the range and domain. So this is really out of scope of what we're going to have in the exam. So I'm not going to do it. Basically, the domain is -5, -4, -2, 0, and 1. And the range is 4, -1, 1, 4, and 3. And we would write this in a set notation, but this will not be on the exam. Okay? But represent as a table and graph will be. So let's represent this as a table. So if x is -5, y is 4. If x is -4, y is -1. If x is -2, y is, I'm just reading off these points here, okay? 0, 4, and 1, 3. Okay, and if we just sketch these, I really need an x, y. Though there's kind of an x and y axis here. That's 0, 0 there. You can't really see it too well. So 0, 4 would be here. That's 0, 4. 1, 3. I'm kind of going out of order here a little bit. That's 1, 3. -2, 1 would be right here. -4, -1 would be right here, and -5, 4 would be right here. So that's it. It's a bunch of points, right? These are a set of points. So it's not really like a function in the sense that you think about it with lines connecting these, like a parabola or a linear function or something like that, okay? But it is a function. It's just a weird function because it doesn't fail the vertical line test. There's no x value that has 2 y values, okay? So this is a function. Okay, state the domain and range of these guys. Now this will be on the exam, so this is much more important. So the domain is all real numbers, okay? And in interval notation, we do that like this, right? This is called interval notation. You could also use what's called double R bar, so you could put like this symbol here if somebody says don't do it in interval notation, but we're going to be pretty much sticking with interval notation. And the range is also all real numbers because it goes on forever in all directions, right? So that's an easy one. Okay, this is a parabola though, and you can see, although the domain is the same, it's all real numbers again. The range is limited. The y values are limited. The y values only go as high as -1. That's the highest point there. So the range goes as low as possible. Always put the lowest number on the left side, comma, and it goes as high as 1, but -1. But because it can also be -1, it's not just below -1, it's also at -1, we put a bracket. So parentheses are used for when it doesn't include it, and infinity always gets a parentheses. And always remember to go left to right, lower to higher. When you go left to right, go lower and to higher. So this is the lower number, that's on the left side, the higher number is always on the right side. And range means all possible y values, domain, all possible x values. Okay, let's go to slide 2. My slide order may not be the same as yours. I imported this, so it may or may not work. But you'll see the problems as you go. F of 4. So F of 4 just means replace x with 4 everywhere. And when I replace a variable, I always use a bracket or parentheses. Here I'm going to use a bracket because there already is a parentheses, right? Okay, and then I'm just rewriting everything else. So I inserted a 4 everywhere there was an x, which was right there, and that's the result of that. And now f of 4, which is the f value when x equals 4, is, I'm going to leave everything alone and just do the parentheses, right? So that's 8. So that's my p for PEMDAS, for parentheses in PEMDAS. And then I'm going to do exponents. Notice I don't drop the parentheses yet. Sorry about this 4. Sometimes this digitizer I have is old, so it doesn't always make 4s very nicely. But anyway, this is going to be 8 times 8, which is 64. Notice the parentheses do not drop because I'm still in E. And now notice the parentheses do drop because I'm going to finish all of my multiplication. So this is going to be 128. Okay, and that's our final answer. f of negative 5. Nothing new here. I'm just going to replace all the x values with negative 5. There's a 2. Notice I write everything else except the x. Whenever I see the x, I replace it with the parentheses or brackets, in this case, and negative 5. Okay. Always bring down the left side. You guys tend not to do that. You need to do that more often. I'm going to do p here. That's parentheses. So negative 5 plus 4 is negative 1. That's p for PEMDAS. Now I'm going to do e. And that is negative 1 squared. So negative 1 times negative 1, which is positive 1. That was my e step. Notice the parentheses are still here because I haven't done multiplication. And finally, multiplication, and we're done. Okay? Over here, f of 4 equals 3 times 4 squared. Again, the 4s don't come out well here, so just bear with me there. They always cross like that. Sorry. And so f of 4, let me see if I can get the 4 to behave. Oh, there we go. Equals 3 times 4 squared, right? So that's 3 times 16. Notice I'm not dropping parentheses because multiplication is not done. And 2 times 4 is 8. Oh, okay. I'm sorry to be consistent here. I'm going to leave this because that's a multiplication problem. I'm only going to do exponents at this stage, right? So I just did exponents. Now I'm going to do multiplication. Now I'm going to drop the parentheses. Okay, and 3 times 16 is 48, plus 8, plus 1. So that was multiplication. Notice no more parentheses. And finally, addition and subtraction. So f of 4 equals 48 plus 8, 56, 57. Okay, and then up here we'll do f of negative 5. So f of negative 5. We really shouldn't have called these both f. One should have been f and one should have been g or something, but it's two separate problems, right? So that's why we're getting away with it. Okay, f of negative 5 equals 3 times negative 5 squared plus 2 times negative 5 plus 1. Okay, f of negative 5 equals exponents first. So this is going to be 3 times positive 25. Negative 5 times negative 5 is positive 25. And everybody else is left alone because that's multiplication, although you could get away with doing it now. So that was e for exponents, right? And then I'm going to do multiplication. Notice the parentheses will drop now. So that's 75 minus 10 plus 1. That was multiplication. And then finally addition, subtraction. And that's 75 minus 10 is 65, plus 1 is 66. Okay? And I'm going very quickly here. It's possible that I make a mistake sometimes. But you'll manage it. Okay? Okay, write an ordered pair for the mapping. So that just means there's going to be a point -1, -3. There's going to be a point 1, -3. But there's another blue arrow, so there's going to be a point 1, 0. That immediately tells me this is not a function. That breaks our rule, not a function, because you can't have 2 points vertically, one above the other in a function. 3, 2. Of course, there are shapes like circles, which are not functions, so it's still an okay shape, but it's just not a function. And 5, 2. Okay? Show each set of data in a mapping diagram, state whether it is relation or function. So I'm going to skip these. We've done a lot of these. They're not really heavily represented on the exam. Let's go to number 7. Okay, find the slope of the line. This one is big, right? This one we do a lot of. So I'm going to do y2, m equals, right? And I always set up my parentheses like this so I don't make sign errors. Anytime I do. Now you can label these. I don't usually do this for speed's sake, but you can. You can put x2, y2, and then x1, y1, and you can do that, for all of them. I won't do that for all of them, but you can. And then y2, so it's 5 minus 1, y2 minus y1 over x2 minus x1. Okay? And that's just 5 minus 1 is 4. Over 4 minus 2 is 2. And of course, that reduces to 2. You can leave it as 2 over 1 if that was like going to be used later in the problem. But right now, we're done. So they just wanted one thing, find the slope. So when we don't want to leave it as 2 over 1 when it's the final answer. Okay? Much quicker here. M equals, right? y2 minus y1 over x2 minus, here you can see why it's so important to have parentheses, okay? Negative 5 minus 0 is negative 5, but here, this is 3 minus negative 1, so that's 2 negatives, right? That's like saying don't not do your homework. That means do your homework. It's positive, right? Don't not, if this was don't, and this was not, right? If I say don't not do your homework, I'm really saying do your homework. It's positive, right? So double negatives become positive. So it's 3 plus 1 is 4. And so that's the slope. Okay, next slide. Write the equation of the line in slope-intercept form that is parallel to these lines. So I'm not going to do 8 because I think I know we did this one in class, okay? So we did this one in class just to save a little time. But they're the same thing. So whatever I do here, you can do for this one too, okay? So it works fine. So this one, it takes a little extra step because it's not in y equals mx plus b format, right? So we really want to put y equals negative 2x plus 4. All I did was subtract 2x from both sides, but I left it in front of the 4. They're not like terms, so they can't be together, right? So step 1 is to get it in this form. Now we can begin the problem. So it says, find the equation of a line. So not this line, not this green line or this black line. These are both the same, just different forms, right? Find a line that's parallel to this line. Okay, so let me change colors because it's a different line. So I'll make purple here. So our new line is going to be similar to this line because it has the same slope. So there it is. It has the same slope. Parallel means same slope. If you think of two parallel lines on a graph, right, they're both going in the same direction, you would count boxes and you'd find they have the same slope. But the B is different, as you can see here, right? So if I had a y axis here, right, this was the y axis, you could see these two lines have two different y-intercepts. So the B is not going to be the same. So this 4 has no value to me whatsoever. Just the slope is all I care about. It has to match mine because it's parallel. And then step 2, whenever we're looking for B, this is true for all of our linear problems, I plug the point in temporarily. And I'm going to be very careful with parentheses here. I'm replacing x with a negative 1 plus B. Okay? And then that's 2 equals, again, double negative here. Negative 2 times negative 1 is positive 2. And I'm subtracting 2 from both sides, so I get B equals 0. So if B equals 0, basically, if I go back to green here, I'm sorry, I'll stay on purple. If I go to purple here, all I'm going to do is take this 0 and plug it in here and then rewrite that problem, right? So the final answer is y equals negative 2x plus 0, but we don't write plus 0, so that's actually the final answer. Okay, that was parallel. Perpendicular is a little different. Same thing, we're going to steal this slope here, this negative 5 slope. But perpendicular means, right, negative reciprocal. Negative means change the sign. And reciprocal, I'm abbreviating here, but it's reciprocal, means flip, right, what you call flip. So if you look here, the slope of this given line that they gave us is really negative 5, and I'm putting it over 1 because that's going to be helpful to me. It's negative 5 over 1. So I'll draw a green function for r. So we're going to write the equation of a line that's perpendicular to this line. So our line is going to be y equals, but it's not going to be the same slope. It's going to be the negative reciprocal of this slope. So that means flip it and change the sign. So the negative becomes positive, and I get 1/5 x plus b. Notice, again, this 1 is of no value to me because two lines that are perpendicular don't usually, almost never, have the same y-intercept. So there's no relation. This plus 1 doesn't tell me anything. However, I can still plug in a point like I always do. So I'm going to plug in this point to negative 1. And I'm going to get negative 1 equals 1/5 times x. Now x is 2. So because it's fraction times integer, I'm going to change that to a fraction. And then I have to find b, right? So this is negative 1 equals 2/5 plus b. We're going to subtract 2/5 from both sides. In order to subtract 2/5, I really need to change this 1 to be a negative 5/5, right? I need a common denominator. And as you know, negative 5/5 and negative 1 is the same. So I get negative 5/5 and negative 2/5 is negative 7/5. So my final answer is just take this line here that you started do, right, that you got the slope for, and just put in the b that you just discovered, which was minus 7/5. Okay? And you can check any of these in Desmos, just plug them both in. The black original one here and the green one that I just did, as well as the point, and you'll read the problem and make sure that that makes sense. Okay, so same thing here. I'm not going to do, well, okay, I'll do this one because I think this one's tough, although I think we did this one in class, but that's okay. So I know we did. So I'm going to subtract 4x. I'm going to get 7y equals negative 4x plus 3. Okay, and then I'm going to divide by 7, so y equals negative 4 sevenths x plus, plus 3 sevenths. Plus 3 sevenths, I forgot to do that. Now, not that that matters, we don't use this, that's why I was not so concerned about it, but to be accurate, we need to do it. Okay, so all I did here is divide both sides. Well, I subtracted 4x first from both sides, then I divided by 7. So now it's in the proper format for me to steal the slope, right? And there's the slope. But remember, it's perpendicular, which means I need to negative reciprocal this. So our line, the red line here, is going to have the opposite sign, so positive, and then 7/4 for my m. There's my x, and of course I need to find my b. I find my b by plugging in this point. So negative 7 equals 7/4 times negative 4 over 1. As you said in class, probably a good idea to use parentheses here and get rid of this dot. That's great. I think that's a good idea. And then this becomes negative 7 equals, now this is negative 28 over 4, right? Negative 7. And then I'm going to add 7 to both sides. Negative 7 plus 7, of course, is 0. So the final answer to this problem is y equals 7/4 x. There's no b, or I should say there's a b, but it's 0. Okay. There's no instructions for 10 and for all these problems. So I think what they're just doing is they're just saying to multiply, right? We're just going to multiply. So we're going to multiply all the numbers together. Okay. That's 80 times 7. I think that's 560. Just double check me. I'm going quick here. And then there's 3 V's, 5 V's, and 3 V's, right? So it's VVV times VVVVV times VVV. So that's 8, 9, 10, 11. So that's V to the 11th. And there are 3 U's here and 1 U here. So U times U is U to the 4th. Okay, over here, this is 80. There's no distributive property. Notice there's no arrows going around like this because these are monomials, right? Being multiplied by the monomials. So that's 80. I have 5 x's here and then x here. That's x to the 6th. And then I have 3 y's and 3 y's being multiplied together. So it's y times y. That's y to the 6th. Okay, here we're going to divide. Division works a little different, right? We're going to reduce, right? So this would be, of course, divide by 2 to get 9/5. And then there's a lot of ways to do this, right? Basically, the fancy way to do this is to take 8 minus 3 is 5 and get x to the 5th. But I'm just going to show it to you, right, the long way, just so you understand it. And then, of course, you can start using the short way. So x to the 8th means there's actually 8 of these, and you can see why this method is not always great. And then there's 3 x's down here, right, x. And, of course, we've got y to the 8th, but who cares because there's nothing, you can't do anything with that, right? But what I want to show you is if you have 3 x's in the bottom being multiplied together and 8 at the top, these 3 are going to reduce, right? And they reduce to 1 over 1 because x divided by x is 1. And you're left with 9x to the 5th and y to the 8th, right? So the final answer is, sorry, I forgot about the 5 down here. My bad. So it's going to be 9/5, right, times x to the 5th and y to the 8th. Okay, so that's what we call reducing. It's really division, right? But we're reducing here. And so we're dividing and some of the x's are reducing to 1 over 1. And that's our final. You could write 9/5 and then put this stuff. That's fine too. It's just a different form. Okay, over here, same thing, right? So we're going to do 14/6. That's an easy one. That's 7/3, right? And then I have x to the 4th at the top and x to the 5th in the bottom. So what does that mean? What that means is, right, think of it like a war. So think of the 4 armies in the top and 5 armies in the bottom fighting each other. Of course, all things being equal, the 5 armies are going to win. So 4 of these x's are going to fight 4 of these x's, and there'll be an x left over, right? 4 minus 5 is -1. -1 means it goes in the bottom. So it's really x to the 1st at the bottom. And then 7 minus 4 is 3, so we can do the quick way here, y to the third. Okay, but again, you could write 7y's multiplied together over 4y's, cross off 4 of them, and you'd be left with 3 left. Okay, so that's the answer to that one. All right, so I'm kind of showing you both ways here. Of course, you want to try to use the quick way if you understand it, but I want you to understand it first. Okay, same thing here, right? So the quick way is multiply. 2 times 3 is x to the 6th, but the reason why that's true is because x squared to the third means write it 3 times, right? And writing it 3 times means writing 6 of these, because each one of them is 2, right? And of course, that's x to the 6th. Okay, so it's really, there's 3 of these being multiplied together. So it's x squared times x squared times x squared. These are all 2's here, by the way. So it's x to the 6th. We'll do the quick way here, though. So that's 2 to the first, don't forget. So it's 4 times 1, so that's equal to 2 to the 4th. And then 4 times 2, so that's b to the 8th. Again, you could always write this 2b squared 4 times. Dot 2b squared, dot 2b squared, right? And you can even go, say, 2, 2, 2, 2, right? So 2.2.2, that's 2 to the 4th. And then dot b squared, dot b squared, dot b squared, dot b squared. And of course, that's 8b's. So you get to the same answer I got to, just a slower way. Same thing here, 7k squared. You can just write 7k, 7k, right? Or you can do 7 squared, k squared. Oh, back to this problem, by the way. We usually, if these numbers are small enough, which this is, we usually write the number, right? So 2 times 2 is 4 times 2 is 8 times 2 is 16. So really, we should be writing this. If it was 2 to the 32nd or something, or 2 to the 10th, or even, we don't really make you do that. Okay, so this one is 7 squared k squared, which is just 49k squared. Again, you could write it twice if you want, like this, which is, I like you to do that for these small ones. It's better, right? Which is 7.7.k.k. Or you could use the power rule, which we're using here. This we multiply the powers. So 2 times 1 makes 2 powers of 2 here. Either way, you're going to get 49k squared. Okay, same thing here. I'll do it the slow way this time. 2x squared dot 2x squared. And that's equal to 4x to the 4th. That's a 4 there. Okay. Here we've got 81, x to the 6th, y to the 4th. Again, it's because we're adding exponents. When you multiply same bases, you add exponents, right? There's an x here and 5 more, right? If you multiply them all together, you get 6 x's multiplied together. Okay, this one is going to be 40 b cubed. Same reasons. Okay, this one's going to be 21 u to the 6th, v to the 8th. And this one's 36 x to the 5th, y to the 4th. Again, I'm just same base being multiplied, adding the exponents, right? I'm just kind of going quickly because we've done so many of the same type. Okay. Okay, so this is different, right? So this is a monomial times a binomial, and of course then times a monomial, which we'll worry about at the very end, right? But this is a monomial times binomial first, so that requires distributive property. Before, we were all monomials, so it was very easy. So this becomes 3x squared, and then minus 21x. Notice, well, this is the big mistake you all make. Don't drop parentheses. Why? Because I'm not done. I still have more multiplication to do. Okay, and this 3 needs to be distributed as well. Even though it's at the end, it's still getting distributed because it's a binomial times a monomial. So finally, that equals 9x squared minus 30, I'm sorry, not 30, minus 63x. I dropped the parentheses now, plus 3. Why did I drop the parentheses? Because multiplication is finally finished. Now, none of these are like terms, so actually that is the final answer. And we're good to go. Okay? Same thing here. Now, you can multiply the 3 first if you want to. I don't usually recommend that. It's usually easier for you to do these 2 first. So I'm going to bring the 3 down, and he's not going to go away. And I'm not dropping parentheses, right? But 4x times 5x is 20x squared. Okay, and then that's just 3 times that, which is 60x squared. Okay, we've done this one all before. I'm not going to explain this too much other than I'm plugging in -3 for x everywhere. So this becomes -3 squared minus 5 times -3 plus 3. Okay, and that equals, right? F of -3 equals. -3 times -3 is +9. That's +15. Negative 5 times negative 3 plus 3. So that's 27. Okay, so find 5 t values, and basically that's going to be negative 2, negative 1, 0, 1, 2, which we always like to do. Those are the easy ones if we can. And then put them in to find the h values. They're calling them h values, but they meant f, so this is just a typo. Or you could just change this to be h, which is probably easier. So they meant to put h of t here, okay? So we put the 5 values in, now plug them in. So when I plug them in, I'm going to get negative, I'm not going to go quickly here just because it's a long problem, but negative 3 times negative 2 is positive 6, minus 1 is positive 5, right? Negative 1 times negative 3 is positive 3, minus 1 is 2. 0, that's negative 1. 1, that's negative 3 minus 1 is negative 4. And 2, that's minus 6 minus 1 is negative 7, right? Plot the 5 points on the graph, label the axes with h and t. So this would be h, of course, or h of t, and this is t. All right, so negative 2, 5 is here. Negative 1, 2 is here. 0, negative 1 is here. 1, negative 4 is here. And 2, negative 7 is actually off the screen. That's 5, 6, 7. So we're going to approximate it. But you can see, right, that if I connect these all together, I'm going to get a nice line. Okay, let me grab the selection tool. And I'm roughing it here a little bit. Yeah, that's good enough. Okay. All right. And there's our line of h of, so that's the graph of this linear function, right? And that looks like a linear function, okay? Connect the dots to show the function as a graph, add arrows at the ends. Okay, I didn't do that, so let's do that. Because the line goes on forever in both directions here. Okay, slide 6. Same thing, just we're finding g of 3, so we're just putting in 3 for x. So that's 3 times 3 minus 9 over 3, right? We should have parentheses down there, though it's not necessary because it's the only thing down there. So this is 9 minus 9 is 0 over 3. Don't forget, please, 0 in the numerator means 0, not 0. It's not the same thing as 0 in the denominator. Okay, here find f of negative 3. So f of negative 3 equals negative 3 squared minus 5 times negative 3 plus 3. Okay, and that's going to be negative. I'm going to do 2 steps at once here, even though I tell you not to do that. Negative 3 squared is positive 9 times negative 1 is negative 9. Minus 5 times minus 3 is plus 15, and then plus 3. Okay, and that's 18 minus 9, so that's 9. So f of negative 3 equals 9. Okay, g of 3. So in order to do g of 3 here, I'm just going to write g of 3 equals 4 minus 2, 3 squared over 3 times 3 minus 5. Okay? Again, I'm going to go a little faster than normal here. 3 squared is 9. Negative 2 times 9 is negative 18. Right? So I get 4 minus 18. And then this would be 9 minus 5 is 4. So that is negative 14 over 4. And that reduces, right? That reduces to 7 halves. Negative 7 halves. Okay? Okay, given the sketch below, find this. So I think I'm on the next page for these guys, right? Yeah. So what I'm going to do is try to steal. Well, okay. Luckily, they got copied over, right? See, so that's right over here. So what is f of negative 2? Well, that means go to the negative 2 line, right? Here's all where negative 2 is, right? Everywhere. And what is the value of this function f? This should be labeled as f here. If they're going to do this, they didn't really, right? Or f of x is even better. So that's the name of this purple thingamajig, right? It's not, it's a what we call a piecewise function in algebra 2. It's a parabola, a linear, and a linear, 3 different linears. But anyway, what does f of negative 2 means? It means at x equals negative 2, what is the f value or the y value, the height? And of course, it's going to be 3. And here, f of negative 8 means where on the graph is this is negative 8. Oh, that's the only point that's negative 8. So when you plug negative 8 in for x, you get 2 for y. So that's 2. Now, I'm interchanging f and y on purpose here for you. Because y, you understand that y is how high or how low you are in a graph. But on this graph, right? This should not be labeled y. It should be called f because that's how they've labeled it here. And so really this should be an f-axis, not an y-axis. Okay? It won't change anything in your answers here. Write this as interval notation. So x is all numbers that are less than 3. So x is less than 3, but it's also greater than -7. So the greater than goes over here. And there you go. Find the slope. All right, same thing as always, right? There's my y2. So y2 minus y1, here's y1, over x2, that's the 4, minus x1, which is this 1 here. So I get basically 1 over 3, or 1/3, right? Okay. 11, where E is the exit numbers on the highway and T is the number of hours driven. How many hours? How many hours? So that means T is the number of hours. So what is T, basically? So there's my unknown. Would it take to get to exit number 88? Well, E stands for exit numbers. So this would be 88. The exit number would be 88. How long will that take? Okay, well, there we can see our equation. It has only one unknown since we plugged everything we know in. And basically, I'm going to subtract 16 from both sides. And then I'm just going to divide by 24, right? Okay. And if you look, 72 divided by 24, does it go in evenly, right? Well, let's just keep reducing, right? 2 goes in there 36 times. 2 goes in there 12 times. Oh, yeah, there you go. It goes in 3 times. See that? So by reducing here, it made my life a little bit easier. But you could have just realized that, 24 times 3 is 72. So anyway, z equals 3. Okay, just 24. I'm dividing both sides by 24, basically. Okay, what is the x-intercept? Okay, we haven't done that one in a while. Well, if you look on a graph, the x-intercept, for example, of this green graph here, let's just do one, right? The y-intercept might be down here, but the x-intercept is here. So it's when y equals 0, because if this is my y-axis, right? On this line here, on this x-axis here, any point on that axis as a y value of 0, So we're going to define the x-intercept. We're going to put in 0 for y. Of course, you can imagine how easy this is. We're going to add 3 to both sides, right? And I'm going to divide by -4. So this is -3/4. It's not the answer because an x-intercept is a point. And the x-intercept has to start with an x value. And of course, the y value must be 0. So there you go. Okay, so here are two, believe it or not, these are points. They're just written in a strange form, right? But this is an x value here, and this is an f or y value, right? So really, that point is this. That's point 1. And f of 0 equals 0. So that point is 0, 0. Okay, find the equation line connecting these or containing these 2 points. Okay, well, y2 minus y1, I should be using parentheses like I've taught you to do, right? So y2 minus y1 over x2, this one minus x1. Notice why the parentheses saved me here, right? So this is -1 over +4 or -1/4, okay? And of course, that's only my m, right? I just found m. Don't forget this is always m, the slope. So y equals the slope plus b, and I'm going to plug in the point that we know. 0, 0 is my favorite point to plug in. It's so easy. So if I go 0 equals -1/4 times 0 equals b, you find out that b equals 0 because all those terms go away. And so therefore, the final answer is this without the b. So it's just y equals -1/4 x, or y equals -x over 4 is the same thing, means the same thing. Okay, I think we got that slide down. Okay, which of the equations has an x-intercept of 12, 0? Well, again, you can see the y is 0 here, right? So it's hard to really just look at it to know how to do it. So I think we're just going to plug 0 and 12 in, right? So we're going to plug in 0 for y here, and we're going to plug in 12 over here. Now you can see this is positive, so it's not going to work because this is going to be a big number plus another big number. So I can pretty much see that these positive answers are not going to work. At least that positive one's not going to work, okay? So this one, we're going to put in 12, 0. So we're going to put 0 in. Does 12 really do that? Let's see. Negative 3 times 12 over 2 plus 18, right? So I'm going to reduce first. So 12 and 2 reduce to 1 and 6. So that's negative 18 plus 18. That one works because that gives you 0. Okay, and of course, in other words, I'm going to get 0 equals 0, and that makes sense to me. Okay, write the equation of a line passing through the point here and it's perpendicular. We know how to do this one. We just went over this. So the scary part here is that there's a 1 in front of the x, so the slope is actually 1/3. But our slope, right, the slope for line number 2 is the negative reciprocal of that, right? So that's negative 3. So we have this line y equals negative 3x plus b, but we just don't know what b is. And we're going to find it by plugging in our point, which they gave us in the beginning of the problem. This is always the way to find b, right? Okay. So this is positive 3, so b equals 3. Okay, so final answer is this slope with a b of 3, right? So y equals negative 3x plus 3. Okay, solve by substitution. So very easy, we're just going to isolate one of these variables. We're going to go for x. So I'm just going to rewrite the first equation, right, by adding y to both sides. That's got me x by itself. Substitution method requires a letter by itself. Then I take that value of x and I plug it into the other equation, which has an x in it. So 2y plus all that stuff I got in my first equation equals 12. And if I drop the parentheses because multiplication is done, this would be 2y plus y, so that's 3y, right, plus 6 equals 12. Okay, and then I'm going to subtract 6 from both sides, so 3y equals 6. And then I'm going to divide both sides by 3, so that's going to be 2. We're not done because what? I need x, right? To solve a system, you're going to get a point. You're going to get a point. So I need to plug that into the original equation here. So if I go, actually, I'm going to plug it in right here. This version of the equation is the same thing. 6 plus 2 is 8. It just made my life so much easier. So x is 8 and y is 2. So that's the solution. Remember to plug that y or x, whatever you solve for, back into the original equation. Okay, and then we'll do elimination. So for elimination, it's already set up for us because we have opposites here. That's really cool. So all our work is done. So that's 0 minus 1y plus 4y is plus 3y. And adding this one is negative 24. So you can see that y equals negative 8. Divide both sides by net 3, by positive 3. And then I want to find out what x is. So I'm going to plug this back into this original equation here. And I'm going to get negative 2x minus parentheses. There's my y value, right? That's my y value. Okay. Equals negative 6. Okay. So negative 2x plus 8 equals negative 6. Negative 2x equals negative 14. I just subtracted 8 from both sides. And then I'm going to divide by negative 2. And x equals positive 7. Okay, solve the system using elimination. So basically, these are not matched up perfectly. But if I multiply the top, actually, let's multiply the bottom one, I think. Yeah, it'll just keep some more negatives. I'll get rid of some negatives. So I'm going to multiply the bottom one by negative 1 and the left side of the bottom one and the right side of the bottom one. Now, notice I'm going to keep myself neat. I'm going to rewrite the original. So this is not the answer to that. This is the original. So I took the original equation here. And now I'm going to distribute to get the second equation. So negative times negative is positive 3x minus y equals positive 38. And that's really important because now my y's are opposite. So when I go to add vertically, I get 11x. And the y's go away, and I'm left with equals negative 16 plus 38, so that's 22. So finally divide by 11, x equals 2. And that is the right answer. Oh, I'm sorry. That's the right value for x, but of course we have to find y, right? So I'm going to plug this back into the original equation. Doesn't matter which one. And I'm going to get 8x plus, oh, I'm sorry. We solved for x, not y. Whoops, my bad. Yeah, I made the mistake. Okay. We solved for x. So this is going to go into x, not into y. So I'm going to plug it in here. My apologies. So 8 times 2 plus y equals negative 16. And this is 16 plus y equals negative 16. So y equals negative 16 minus, I can't really fit it there, so stay with me. All right, let's do it again. So this is 16, so y equals minus 32. I should have just done that from the beginning. I don't know why I didn't. So, because this will be 16, right, plus y. This will turn into 16 plus y equals negative 16. And I want to, right, subtract 16 from both sides to get y by itself, so I get negative 32. So the final answer is this. Again, just double check my work. Put those both in Desmos and we'll see. Solve either method. I'm going to use elimination method because I already have it set up. These are opposites. So when I add, I get 2x. X plus x is 2x, right? Equals 4. And then x equals 2. What does y equal? Well, I'm going to put a 2 in for x right here, right? So I'm going to get 2 plus y equals 4. And I'm going to subtract 2 from both sides. So they're both at 2, 2. That's my answer. Well, I should say. They're both 2, 2, but I mean, it's the point 2, 2, right? So I got to put a box around this. I don't want to circle that. It'll look confusing. Okay, that was 19. Elimination method that's already set up because these are opposite. I know there was a little bit of a typo there before. So now I'm going to add them together. So that's negative 9x plus 0 equals 27. Divide by negative 9. So x equals negative 3. Now to get y, I'm going to plug this back into either equation, probably the top one here. So I'm going to get negative 4x. I'm sorry. I'm going to plug it in for x. I keep doing this. I'm going to plug it in for x. So it is negative 4 parentheses negative 3 plus y equals 6. Okay, and that's going to be 12 plus y equals 6. I'm going to subtract 12 from both sides, so y equals negative 6. Final answer is, of course, a point, so make sure you write it as a point. There it is. That is the intersection point of those two lines. How do I check? Just put them both in Desmos, and again, like I said, I can make a mistake if I'm rushing here. Solve using elimination method. Okay, well, they're not the same with an opposite sign, so I need to multiply the bottom equation on both sides by negative 1 to get it to match better. So I'm going to just rewrite the first equation. I don't need it right now, but I will need it in the future. Excuse me. I just rewrote the first equation. Now the second equation, we have to multiply by negative 1. I'm going to distribute that. Be careful. So I'm going to get 3x minus y. That's really important because now I have opposites, right? I have opposites right here. And then equals 5. Okay, negative times negative is positive. Okay, now we add them up. We get 11x. This is 0, which is what we were hoping for, equals 11, right? Negative 16. Oh, sorry, negative 11, right? So negative 16 plus 5 is negative 11. So I'm going to divide both sides by positive 11, and I get x equals negative 1. Now to get y, I'm going to plug that negative 1 back into the original equation. So I'm going to get 8 times negative 1 plus y equals negative 16. Okay, and that's going to be negative 8. I'm going to subtract negative 8 from both sides, right? So that means I'm going to add 8 sides, plus 8 to both sides. And I'm going to get, of course, I'm going to get 0 here, right? But I'm going to get y equals negative 16 over 8. And that's a negative 2. Not done, because I got to find x. So I'm going to plug this back into the original. Up here. Oh, no, I'm sorry. We already did. We found x. I'm sorry. I forgot. Yeah, we found x. So y is negative 2. So the final answer is negative 1, negative 2. Put the x and y value in an ordered pair. Okay, solve by elimination. to have to multiply one of the, it doesn't really matter what. I'm going to multiply the top one by 3. It's just the first thing I see. And that first equation is going to change now to become negative 6x plus 3y. Got to distribute that. Equals 6. And I'm just going to bring the second equation over, and you're going to see that it's already set to go for elimination, which is great. So now I'm going to add, and I'm going to get 0, and this is going to be 3 minus 5 is negative 2y equals 18. Okay? So divide both sides by negative 2. So we get finally y equals negative 9. Okay, I think it's last slide coming up. No, it's not last slide. Okay, 12. Yeah, it's last slide. It's just graph. Okay. Finally, we did this in class. I'll briefly do it. Okay, and they tell you to use the graph. I can't change that on the last slide. Okay, so find the equation of a line that's perpendicular to y equals 2, passing through negative 1, 5. So I'm going to make an x and y axes here. Whoops. Let's put it over here. Okay, x and y axes. Not perfect, but it'll work. Oh, hey. Okay. So perpendicular to y equals 2 and passing through negative 1, 5. So negative 1, 5 would be here, and passing through negative 1, 5, sorry, parallel to y equals 2. So here's y equals 2. And they're asking us for a line that is parallel. Oh, no, sorry, perpendicular. Okay, let's do this one first. I was kind of looking down here. Let's do this one first. So find the equation of a line that's perpendicular to y equals 2 passing to that point. Well, it's actually pretty easy because perpendicular means up and down. So I know it's up and down. So in other words, it could be anywhere up and down, except they also gave us a requirement that this goes through that point. So I have to move it over here. And that line should be super easy for you if you've done vertical lines with me before. That is y, I'm sorry, vertical lines are x. That's x equals negative 1. That's the name of the line. Super easy problem. Almost as easy as this one, but the next one's even easier. Find the equation of a line parallel, spelled wrong, by the way. 2L should be here. Parallel to y equals 2. So it's same exact problem, same point. So everything's the same except it's parallel. So let's go back and see what that looks like. So I'm going to get rid of this green line here. I want this blue line to be parallel to this purple line. Okay, so I can be here or anywhere I want to be. Well, yeah, but not really, because this one has to go through that dot. All right, and the name of that one, by the way, is y equals 5. That's just the y value of this dot, right? Whereas, and I didn't write the other one, so this is y equals 5. Of course, you can type it in there. And this one was x equals negative 1 because it's got to go through that negative 1 value. Very, very simple problem. Okay, that's about it, guys. Good luck on the exam. I will talk to you tomorrow.